Today we're going to be unboxing and taking our first look at the 3DMAKERPRO Magic Swift Plus 3D scanner. So inside the box, most of it is contained in this nice kind of semi-rigid carrying case. So they included this ceramic bust of David here. This is going to be a good example or test scan object, if you will. Because it's matte, it makes it very easy to scan. If you have glossy items, you have to take a few extra precautions. And there's a lot of small details here, so we can really test its ability to grab those minute details. But let's get into the important parts here. What's in this case? So we have a manual and a USB stick here. This manual has it's not a manual, it's a hardware packing list. So it's just got all the different components and computer system requirements here. And so on the requirements here, for the minimum specs of your machine, you're gonna want an Intel i5, 8th gen or higher, 16 gigs of RAM, and an MX250 GPU or higher with at least 2 gigs of VRAM on the GPU. So very low minimum requirements. Recommended is a i7 8th gen or higher again, 16 gigs of RAM still. More is always better, of course. And then an NVIDIA 1060 GPU with 4 gigs of VRAM. So really not heavy on the system requirement side of things. And then it's got a list of all the components on the back here and some assembly instructions. But as you're going to see, it's very, very easy. So this case is really nice that it provides kind of a barrier between the stuff that's in the zipper pouch here and the more critical bits. In the zipper pouch, it seems like there's just the turntable top. Yep. But I know some people put their cables and stuff in here. So the turntable top has a pattern in it, and that makes it easier for the scanner to kind of keep track of that surface as it's rotating around the turntable. And then in here we have the turntable, and this turntable is using micro USB, and this has a little insert on it, so it'll just rest right on top like that. I should point out the entire inside here is molded to fit every component perfectly, so nothing's rattling around and nothing's going to get damaged or even scratched. So this tripod here is pretty beefy. Seems to slide up, and it's got markings for the height. And as you kind of twist it in a clockwise direction, it locks itself in, and then counterclockwise releases it again. And then once it's raised, I can bring down these feet. A little counterintuitive, because normally you'd expect them to be almost this way. But when you flip them down, you can rotate this to make sure that they don't accidentally come back up, so it stops them. And they've got little rubberized feet on them, so there's that. So that's the max extension. And then you've got the little ball mount and a kind of a standard tripod screw and cork. And on that is where we will screw the scanner. Bit of a different form factor from some of their other scanners. So this is it. On the back, we have a USB-B, USB 3B, and then you've got this 2-pin little barrel connector here. So that will be for this guy. And there's a little notch on it, so it only goes in the one orientation. There's also a little red dot that lines up with the red dot to make that easier to determine. There we go. And then the other connector here has the USB-B on it and goes in there. And it's got these little screws to firmly attach that so it doesn't accidentally come unplugged on you. Now, especially if you're using this as a hand scanner by hand, it stops you from having to worry about there being a tug on that cable and popping that loose as you're moving around your object. But for our test, we're going to screw it onto the tripod. In this little bag here, we have all the different plug connectors. And again, with one of these little screws, I believe this is intended to just screw into here. Yeah. On the other side of this cable, we have a female barrel plug and a USB-A. So the barrel plug is to take power from this wall adapter. So that just plugs in there like that. And then data to the PC. This wall adapter, we need to put the appropriate plug on it for our region. So for us, it looks like this. But you know, if you were down south in South America, yours might look like this. Just slide that on like that, and then plug that into the wall. We've got lots of extra cordage here. I just haven't unraveled it yet. And then this is obviously going into your computer. So we have one more USB cable. It has a micro USB on the one side to go to the turntable. And on the other side, it actually has a really small barrel plug. And so unlike some other scanners that we've seen where you need to provide your own wall adapter, or you just plug it in via USB into a computer or something similar to provide power to the turntable, this actually connects into the side of the scanner right there. And then obviously into the turntable. There we go. So that's the setup. And this is obviously for scanning an item on a turntable like our bust here. And we're gonna probably scan him in multiple orientations. So as he's spinning around, we're getting kind of a 45-degree angle, top-down kind of view. And then we would probably scan him again like this, and then maybe once again like this, and lay all those meshes over top of each other in the software. In the manual, it does mention to make sure that you have this plugged into a USB 3 port on your computer. The fact that it's blue tells you it's USB 3. Most of these things are backwards compatible. I'm not sure it's pushing enough data to need that extra bandwidth, but just be forewarned that from an official support perspective, it has to be USB 3. And I'm gonna assume that the software is on this USB stick, so let me grab my laptop and we'll go through the software install and we'll figure out how to make this thing work. Okay, so I've got everything hooked up to my brand new laptop here. You can hopefully, or maybe not hopefully, hear the small fan inside here that's keeping everything nice and cool. It's plugged in through a standard USB-A connector. It has the inline power. And then this guy here, as I'd mentioned, is going to the turntable. So the turntable, unlike some of the other scanners that we've looked at in the past, is controlled by the scanner through the software. So you don't have to have this constantly turning. It's all kind of coordinated for you. So with all that said, we got to install the software. Let's go get that. So I'm going to open Edge in this case. You can use your browser of choice. This is not my browser of choice, but it's what I have. And we're looking for JM Studio, so we could go to their website directly, or maybe I'll just Google it here. There we go, 3DMAKERPRO. And let's get the software. There's the manual if you want an electronic copy, and we want the Windows copy of JM Studio. Newest version. I'll also point out here that it's nice to see that they have support across all the major OSs. You can also run on iOS if you wanted to use an iPad for that, or an Android tablet too. I don't know if they're feature parity between them all. I wouldn't be surprised if they weren't, but I can't comment on that either way. So now that that download is done up here, I can just click on the downloaded file. Maybe I jumped the gun, not quite done yet. There we go. Open file. And it's going to be your standard installer that you've probably done many times before. Yes, I agree. Okay. So I'm going to read and agree to the terms of service or terms of use. I can choose an alternate location to install it to. I can add a desktop shortcut. I'm just going to kind of leave all those defaults. I'll hit install. Okay, so it's asking us if we need to support the Magic Swift or Magic Swift Plus. And so we will say yes, we need to support that. Hit OK. There we go, it's done. So we'll hit start, and we'll hit start scanning. So the scanner failed to connect. So because I already had the scanner already connected through USB, I'm just going to remove that and then plug it back in and see that it detects it and installs it now that the drivers are installed with the software. So on this particular laptop, we have a very high resolution screen. I think it's 3180 by 2160, somewhere there. And we're having some scaling issues. So you can see that some of the text is running right off the screen here. And as I go through here, there's supposed to be some, you can see things are getting cut off, right? So I'm going to change my machine's resolution down to something maybe a little more standard, like 1440p, and just see that it works correctly at that resolution. So I went into the display settings in Windows here, and I chose 2048 by 1152 and resized the screen. And then we'll just run JM Studio here and see if that corrects the scaling issue that we had. So we'll hit start scanning. We can also see here that I think the serial number of the device, so it's detected it, which is a good sign. There we go. Now we can see all the text, so that's better. So it gives you a little kind of quick start guide. Shows you the user interface, identifies certain key areas that'll be referred to, how to scan objects or some kind of guidelines for scanning objects. Be sure to scroll down near the bottom to see the additional text there. But certain objects require treatment before scanning, so things that are transparent or that deform or that are shiny or reflective. So for those objects, you can put a spray, which you've seen on the channel before, a purpose-built spray. I've heard of people using like a Gold Bond medicated powder spray of sorts. In this case, they say foundation liquid or flour, anything to make it matte and no longer transparent or shiny. So there are different scanning modes. So depending on the distance you're going to scan from and the size of the object, they suggest some different scan modes. So we're using Magic Swift Plus, so we can scan from 400 to 900 millimeters away. And then here's the table mode object size recommendations. We're just scanning a small object. We're just scanning this bust here. And I also have a small plastic object that's a little bit bigger than that. On the left-hand bar here, we're going to see if we are too close or too far away from the object that we're scanning. We want to keep it in that Goldilocks zone, in the excellent zone there. And then how to position your item as far as the preview window goes, how far away you want to be from the item, where you want your center point to be. And so you kind of want it to be here, center of mass. You can see the whole table. You also, as far as brightness goes, you don't want to have it too bright. And you'll see in a moment that in the preview window, it shows you it gets red when it's too bright. So you can focus on geometry or you can focus on texture. In this case, we're going to be doing geometry right now. And it talks about the preview, initialization, and scan, kind of three-stage process you go through. So preview the item, you initialize kind of the table or the bed, and then you do your scan. And it knows now that that pink area that you did during the initialization is what it's going to remove from the resulting scan. Here's a bunch of hotkeys and controls for it. I'm using a touchpad, not a mouse, so it's a little bit more complicated. But you could kind of save these for quick reference. Some of them are also up here at the top, a little shortcut guide. So let's go in. All right. Right now I'm in easy scan mode, and you can actually see that even though this is horizontal, the image is flipped 90 degrees. We want to actually be doing a table scan. And give it just a moment. We'll hit preview. There we go. So this is where we want to preview. I can see the whole table. Set it kind of center of mass there, like that. And now you can see the red that I was referring to earlier. So being that this is a white object, you don't need a lot of brightness to properly scan it. We're also in a very well lit room, so that helps. But in this case, we'll turn the brightness down so that we're not seeing any red at all. So somewhere right about there is good. I'll leave the sensitivity where it is. Actually, I'll leave all these other things where it is. Now you can see on the left there, it does say that we're too close. So I'll just kind of slide the scanner back, or alternatively, you could, move the rotating table away. Now it says excellent. Reposition this right in the middle. There we go. Perfect. So we'll now hit this button to stop. And now we're going to remove the object as it says at the top there and do initial. And with any luck, it's identified the bed as being pink, so that's the base that it's going to remove at the end of the scan. That looks good. Now I can place this back in the center and we'll do our first pass. Now per pass, it will do just about 320 frames. You can see that counter at the bottom there going up. We'll just let it max out that frame count, which gets you about 360-degree view. And then if we need to capture more details or fill in some voids, we can then maybe turn it on its side and capture again, just in a different orientation to get a different perspective on some of those angles. So after that one, as they call it, table scan here, 320 frames, this is what we're left with. And we can click and drag to rotate it around. Don't be afraid by how bad it looks. It actually turns out a lot better once you do like the mesh repair stuff. What's interesting here is that it has identified part of the base there as being part of the bed, kind of wrapping up the base, and that's not quite accurate. It's, it ends right there. So let's append this, as they say. So we'll hit append. First, I'm just going to move it onto its side. Make sure it's stationary. Hit append, and then I'll just hit scan. And I may need to reposition the scanner a little bit here. No, that should be fine. Okay. And we're still in the excellent zone there on the left. And as I mentioned, each time we start a pass and end a pass, the table's automatically rotating, controlled by the software there. So that's what that pass looks like. Now, obviously, it's going to have a hard time getting the back of the head because that is towards the bed there. But the rest of it, no problem. So between these two scans here, we should be able to construct a fully meshed object. So let's align these two scans. So that's the next step, is align. Auto align, we have to choose two different scans to auto align. So I'll select both of those and then I'll hit align. What's going on here? Drag one object to align. Oh, sorry, this scan is not visible. So you can see the little eyeball there. It automatically made the first scan invisible when it scanned the second. So there's the first scan. Of course, they're different orientations. But we'll hit align now that we have two visible scans. Okay, it says finished. Yes, it looks like they are aligned. Now we do want to remove the beds. So I'll hit edit and I will delete the selection. And that has now deleted all the pink selected areas. So now we're just left with this. And you can see that it's a little bit fuzzy on the base there where the one scan kind of cut it off. So I'll be interested to see how this repair works. But we will hit process. And I'm going to call it head because I'm creative. I'll hit apply. These are the two scans that we're going to merge. So hit apply. Okay. So export processed data now. I could hit apply, and then it's asking me to save an OBJ. So I could call this head, or I could just wait a moment and kind of preview it first before I do my export. So you can see there's a little bit of an issue here as a result of it thinking that that should all be cut off. And I think there's a small hole here and here, as we can see. So now our options are to do additional table scans, as they call them, from different perspectives. I could do another one like this. I could do another one on its side. and so on. I mean, some objects are a little easier to place in multiple orientations than others, but then take 3, 4, 5 of those scans and merge them. If the level of detail is not super critical, you can actually just have the software kind of fill in the holes for you, right? Now, this right here is not going to fill and be representative of the original, but these here, you'd probably be hard pressed to tell the difference in this particular case. So I'm going to actually attempt that. I'll show you both options here. So I'm going to go repair. And now we can see that those holes are closed. And even on the back here, it's closed. Now it kind of just averaged it out and did a diagonal slant there. But up in the hairline area, that looks fine to me. Now, like I said, if you were going for accuracy, I'll just reset this. And I'm gonna actually delete this fusion here. And I'm gonna do another table scan. So I'll hit preview. Yep, that's the object. We'll do the initial to grab the bed. And I am just going to point this down just a little bit there. Okay. And then I'm going to do this face down and scan. So once again, it is kind of creeping up onto there. I'm not sure the proper way to fix that in this scenario, but let's see if we can make all 3 of these merge. So we definitely need to align them again. The first 2 are aligned, but the third now needs to be reoriented. With any luck, yeah, that looks pretty good. Then we'll hit delete selection to get rid of the pink. And then we'll hit process. All 3, hit apply. So you will need to be patient as you are doing the processing. That probably takes the most amount of time. And that's obviously going to scale with the number of scans that you're trying to process at the same time. Okay, so this time I'm not going to hit apply. I don't want to export it quite yet. I just want to take a look. And as we can see, it's corrected the base here. So between the 3 different scans, it's able to figure that out. We also don't have any holes anywhere in the model, so that's a good sign. If you do have minor holes, you can either fix them here or you can fix them sometimes in a slicer, but ideally we don't want to have any whatsoever. So we're good. We're going to export this. File, export, and I want to output it as an OBJ. I'm going to call it head. I'm going to save over top of that one right there. I want to replace that. And so now you can load that up in your slicer of choice. For a model like this, to retain all that detail, I'd probably use a resin printer of sorts. And this may need a few supports specifically on like the nose and maybe some of the hair or the brow area. But you'll be able to retain the maximum amount of detail in resin. One thing that I didn't show here, and I had happen on my personal computer at home, was I needed to import the calibration for this particular scanner. So to do so, as long as you're connected to the network, if you hit import calib, your options are to give it a file to import, or you can actually say network download, which will phone home and get the calibration file for this scanner and hit OK. Now I don't know if that is per machine or if when you download that calibration that it's somehow stored here, and maybe that's why I didn't need it here. I'm not clear on that, but it might just be a safe bet to import that on every new machine you plug it into, since I clearly don't understand why that didn't happen here, but I figured I'd point that out. Well, hopefully you found all of that useful, and now you feel much more comfortable using your very own 3DMAKERPRO Magic Swift Plus. Remember to like and subscribe and ring that bell down below to get notified when we upload more videos like this. Thanks for watching.